So one more thing I want to show you today is this. When we play the game and we look around while we are close to the car, we always hear the car engine sound at the same volume. We hear it panning left and then right, but we always hear it at the same loudness, at the same volume. And this is kind of annoying, I think, because when I'm not looking at the car, I don't want to hear the car at the same level. Also, I think it's a human thing. Our ears are naturally facing forward so that we hear more clearly and at a higher volume the sounds that are in front of us, the sounds whose source we're looking at. This is something that is similar to the polar pattern of a microphone. So, for example, a cardioid microphone works like this. The sound emitters that are in front of him, we hear them at full volume, but going towards the sides and behind it, we hear much less of those sound sources. So I want to create something like that in Wwise. In order to do that, we have to create two new RTPCs, and they will be azimuth and elevation. Both of these RTPCs are tied to built-in parameters. So azimuth, it goes from -180 to 180, and elevation, which goes from -90 to 90. So what are these parameters? I'll show you this image. So let's imagine that we are the observer and we're facing the north in the game. The game object is the star, so the azimuth will be the angle on the horizon plane from the direction we're facing to the horizontal coordinate of the game object that's emitting the sound. And the elevation will be the angle from the horizon to the y coordinate of the star. So let's go back to Wwise and work with these two new parameters. In the vehicles actor mixer, let's go to RTPC and create a couple of voice volume curves. The first one will refer to azimuth and the second one to elevation. So let's work with azimuth. We were saying we want the sound to be louder when we're facing it, but we want it to be quieter when we're facing the opposite direction. So this curve kind of represents that. When the angle, which is on the x-axis, when the angle is 0, we don't want any attenuation. So the voice volume is 0. At 180 degrees, I wouldn't say -200, but maybe we could attenuate it by 10 dBs. The curve, if we want a cardioid, something like this would work, but I think that an S-curve works very well. And for the elevation, we want to do the same thing, so maybe it's better to just copy this and paste it. In my experience, I don't want it to influence the volume of the sound so much, so I attenuate it less than the azimuth. We can also apply more curves for low-pass filters and high-pass filters, but for now, I think this will be fine. So let's go back to Unity, generate the sound banks, and see if this works. Okay, so we're facing the car, full volume. That's great. Let's try and rotate. Okay, the volume is much lower. And now when we're facing the car, the volume is at full volume. Again. So I think this is a very nice addition, and I think it helps gameplay as well, because as I was saying before, I want to be able to listen what I'm looking at more than what's behind me. And also it helps the user to locate sounds, because he can be guided by his earrings. So if he looks around and he hears something become stronger in volume, he can go in that direction. One final thing, what if we use these parameters for creative reasons? So for example, let's get rid of elevation, and in azimuth, let's shift this to 0 and shift this to -200. This would work something like Boo in the Mario series. So, what's his movement pattern? He flies towards you only when you're not facing him, and when you stop and look at him, he just covers himself and he doesn't move. So, this would be an audio equivalent to Boo. Let's build the sound banks and see what happens. Okay, the car makes no sound. We walk in another we look at another direction and we hear the car at full volume. We look back at the car and it's not playing any sound. So okay, yeah, this was just to make you think about possible alternative solutions by using these built-in parameters. So I hope you enjoyed this video and see you next time.